So on the screen now are the extra practice at the end of section 2.6, and I would call these the boat problems, the problems that we did on the last video from the extra practice talked about a fast person and a slow person, either walking, running, or biking. Um, those problems solve similarly but differently than the boat problems. Um, in the fast person, slow person problems that we've done so far, there are two people and I get two answers. So in those problems, I've got two answers, the speed of the fast person and the speed of the slow person. And for the rate box, only one of the rate boxes got a sign. Either one got a plus sign, the other got a minus sign. One got a plus sign, the other got X, or one got a minus sign, the other got X. So these are actually different for the kinds of problems that I'm about to do. We're about to do the boat problems. I call them boat problems because the first word says a boat, as opposed to the first word saying a fast person or a slow person. And two answers. In the boat problems, I have the same structure of the box, but in the boat problem, ultimately, all the boat problems that we're going to do talk about a boat traveling on a river. A boat's gonna go one direction, either with the current or against the current. Then it's gonna turn around and go the other direction, either whatever the other direction is. But there's just one boat and there's one river. Somewheres in the problem, it's gonna give me the speed of either the boat or it's gonna give me the speed of the current, and it's going to ask me to find the speed. So there's a boat in a river, and I'd like to know the speed of both. Just like in the fast person, slow person problem, I wanted to know the speed of both people. Well, in the fast person, slow person problem, I didn't tell you the speed of the fast person, nor did I tell you the speed of the slow person. I had to get both of them. In the boat problems, where I have a boat on a river, goes up against the current, turns around and goes with the current, there's two things. There's a boat and there's the speed of the river. Unlike the fast person, slow person, one of those numbers is given to you. So you don't need to give me the given. I know what one of the speeds is. So in these, there's only going to be one answer because of the two unknowns, or what could be unknowns, the speed of the boat and the speed of the river, one of them's given. So there's only going to be one answer. That's one of the big differences between the fast, slow person problem. And the other of the big differences is both rate boxes get a sign. In the fast person, slow person, one of the rate boxes had an X, the other either was X plus a number or X minus a number. So conceptually, here's kind of what's happening. We're assuming there's a boat with its accelerator locked in a certain, just the person isn't pushing the gas pedal, not letting up or pushing harder on the gas pedal. And the gas pedal, if a boat has a gas pedal, is locked. And if the person is traveling with the current, the boat's going to get sped up. It's like walking on a moving sidewalk in a airport. With the current, the boat's speed is going to get sped up by the speed of the current. So usually I would say the rate in the with going the direction of the current, it's going to be the boat speed without the current. plus the speed of the river, or speed of the current. And usually, for the with the current rate box, I say it's boat speed plus current or river speed, because it's going to get sped up. And against the current, going the direction opposite the way the water is flowing, the river's going to slow you down, and the rate box going against the current is going to be slowed down. If the boat's accelerator doesn't move, then the boat speed without the current, if the river just stopped, the boat would be going at a certain speed. It's going to get slowed down by the speed of the current. So again, so without the current, or against the current, should I say, or going the opposite direction that the river is flowing, the rate box is going to be the boat speed without the current minus the current. It's so all my rate boxes are going to look the same. With the current, my rate box is going to have a boat speed plus a current speed. Against the current, my rate box is going to be boat speed minus current speed. And one of these two numbers is going to be given, and I'm going to put the number in the appropriate spot. If I'm given the boat speed, the number that's given is going to go before the signs. If I'm given the current speed, the number is going to be put after the signs. Let me just try to do a problem real quickly to show you. So real in my mind, when I do a boat problem, the big difference in the boat problems table-wise is that both rate boxes get a sign. Answer-wise, there's only one boat and one current. I'd like to know the speed of each. I know the speed of one. I need to find the speed of the other. There's only going to be one answer because I know the other. So as I read my sentences, I do them backwards for just so you don't, so they're not exactly the same. And in these boat problems, I do the distances in the first sentence. So let me get the distances done. So there's a boat traveling two directions on a river. It goes one direction, turns around, goes the other direction. The whole time it leaves its accelerator locked. So the first number I see is a boat travels 28 miles against the current. That's a distance. That's a distance of 28 miles going against the flow of the water. And then in the same time, this same time is the nice thing that allows me to set the time boxes equal to each other once I create the time box. And the same times it takes 52 miles takes to go 52 miles with the current. That is with the current, with really nicely read there. So done with the first sentence. The second sentence is going to give me the number to fill up the rate box. If the number in the second sentence is the speed of the boat, I put it before the signs. If the number in the second sentence is the speed of the river, I put it after the signs. And I'm going to try to find the other number. So I go to the second sentence. If the speed of the current is 3 miles per hour, so because it's the speed of the river, it goes after the signs. So the rate's going to be sped up by 3 miles per hour when you're going the direction of the current. It's going to be slowed down by 3 miles per hour when you're going against the current. And then it just says find the speed of the boat in still water. The B is the only answer I need. And it's the boat speed if there wasn't a current. If the river stopped, this is how fast the boat would be going. I'm basically done because the algebra is identical now, other than I only need one answer. The time boxes are distance divided by rate. Numbers are bigger, but structurally it's going to be the same. So the time box for with the current is going to be 52 over b plus 3. against the current is 28 over b minus 3. So this is the big deal. When we did the fast person, slow person problem, only one of the right boxes got a sign. When I did the boat problem, both right boxes get a sign. The right boxes all start off the same, and I take the number from the second sentence and put it in the right spot of the right box. Fast person, slow person, because I didn't know the speed of either person, I needed two answers. In the boat problem, I have a boat speed and a current speed. I don't need to give two answers because I already know one of the speeds. I'm only shooting for one answer. Here I'm only shooting for the boat speed because I know the current speed. So I'm going to solve by cross multiplying, and my whole answer is just going to be 10. I don't need to get two answers because I know the other number is 3. Numbers are calculator worthy. We cross multiply. One side is going to be 52 times b minus 3. The other side is going to be 28 times b plus 3. Doesn't matter which side you do the multiplication on. You can have them flip-flop from mine. On the left-hand side, when I clear the parentheses, I'm going to get 52b minus 156. And on the right-hand side, I'm going to get 28b plus 84. I would usually do this algebra in one step, but sometimes students have a hard time following that. I need to get the letters on one side, the numbers on the other. I would normally do that in one step, but just because it's the first problem and try to make it easier to follow, I'm going to get the letters on the left side by subtracting 28b from each side. And then I'm going to get the numbers on the right side by adding 156 to each side. And I generally would do that in one step rather than these two lines. This is almost silly. And I broke out my calculator because I didn't want to do this math in my head. And then once I get that set up where the letters are on one side, the numbers are on the other, I solve by dividing. Here I'm going to divide by 24. That I can do without my calculator, especially because the answer is already written. That's the only answer I need because the other, what could be unknown is the current speed. It's 3 miles per hour. So my answer, the speed of the boat, if there wasn't a river, is 10 miles per hour. So technically, it's traveling 13 miles per hour going with the current and 7 miles per hour going against the current, but that's not asked for. Let's set up number 1 together of these extra practices, and you can finish it up. So the first sentence in number 1 gives me distances. The shorter distance is going to be against the current. The longer distance is going to be with the current because they're traveling for the same amount of time. And that traveling for the same amount of time allows me just to set the time boxes equal to each other. So in number 1, since you've paused the video, now you're just watching to check if you didn't get the 12 miles per hour. The distances are 48 miles with the current, 24 miles against the current. The right box is always boat speed plus current speed, boat speed minus current speed. The second sentence is going to give me a number to change one of the letters into. In the second sentence, it says if the speed of the current is 4 miles per hour, so that C, I'm going to change to 4. Both the right boxes in the boat problems get signs, but I only need one answer. Once I get the right boxes filled in, once I have the left part of the table set up, I'm going to divide to get the time. And then I'm going to cross multiply. I'm going to set the equations equal to each other. And I'm going to cross multiply. And I'm not going to do all that algebra. You need a calculator, but the algebra is not ridiculous, hopefully. So there's no real variation in the boat problems other than the number that I get in the second sentence might go before the signs, and that depends on what it is. If the number in the second sentence talks about the speed of the river, or the speed of the current, it goes after the signs. If the number in the second sentence is the speed of the boat, it goes before the signs. So we have a couple more examples here, 3 and 4. I'll do 4. You might be able to do 3 without me. I know in all these boat problems that the rate is boat speed plus current speed and boat speed minus current speed. I'm going to change one of those letters to a number, and that's based on the number in the second sentence. First sentence gives me the distances. The first distance I see a boat travels 57 miles downstream with the current. That distance is the with the current distance. In the same time, it goes 39 miles upstream against the current. That's the against the current. Done with the distance box. And then it says if the speed of the boat is 16 miles per hour in still water. So that 16 is not a current speed, it's a boat speed, and it's going to go before the signs. So my algebra is going to be a little bit harder when the number goes before the signs. But the rate box, this is the variation of the boat problems. The rate box can be, the number can go after or before the signs. But regardless, once you get the 4 boxes filled in, time is distance over rate. And I'm going to set the boxes equal to each other and cross multiply, because somewhere in the problem it says that the boats go for the same amount of time. Doesn't matter when I cross multiply which way I do it. I'm going to go 57 times 16 minus c on one side equals 39 times 16 plus c on the other, and the c stands for the river speed or the current speed. I only need one answer because I already know the boat speed. The boat speed is 16 miles per hour. Maybe I should use knots, but I don't really know knots so well. So there's only one unknown. Now I'm going to clear the parentheses. On the left hand side I'll go 57 times 16, 57 times 16, and get 912 minus 57c. On the right hand side I'll do 39 times 16 and get 624 plus 39c. Most students like to get the letters on the left hand side, so I'll do that just to be consistent with how you might do this. I'll minus 39c from both sides. I'll bring down the 912, and minus 57 minus 39 gives me negative 96c. On the right hand side, the 39's cancel. I'm left with the 624. Now I'm going to minus 912 minus 912. On the left side I have my minus 96c. On my right side, 624 minus 912 gives me minus 288. And then I'm going to divide by minus 96, divide by minus 96, go minus 288, divide it by minus 96, and that's going to give me 3. So c equals to 3. That stands for the current speed or the river speed. You see my answer is that. So I should tack some words to my answer. Current, spelled nicely. Speed is 3 miles per hour. So your problem 3 should work the same way. So pause the video, take a second to do it. I'll set up the boxes because that's really the hard part. The numbers in the first sentence give me the upstream distance first, which is 36, the downstream distance second, which is 44. Always the with the current's going to be the bigger number because they're traveling for the same amount of time. And, oh, look at this. This is a trick, or not a trick. It's more like problems 2. When I look at your problem, this one's not the same. Here, the speed of the current is 2 miles per hour, so the number that you're going to get in the box has to go after the sign. There's a problem 5 that we need to work on here in a second. Problem 3 was more like problem 1 and 2. The number in the second sentence is the speed of the current, not the speed of the boat. And so because it's the speed of the current and not the speed of the boat, it goes after the sign. So in problem 3 on the extra practice, it's really more like problems 1 and 2. I'll show up problem 5 on the extra practice pretty quickly here so you can give it a go. You should be able to run through that problem and still get 20 miles per hour. Where do I have problem 5? Oh, yes, I do. So problem 5 on the extra practice turns out to be like problem 4. If I laid these on top of each other, they're more like each other. So why don't you pause the video and try to do 5. The first numbers in 5 are the distances. The longer distances is always with the current because they're traveling for the same amount of time. So the 54 and 46 in the first sentence are the distances that goes in each direction. In the boat problems, both rate boxes get a sign. In the number in the second sentence, if it's the speed of the current, it goes after the sign. If it's the speed of the boat, it goes before the sign. And in problem 55, the number in the second sentence is the speed of the boat, so it goes before the signs. So your rate box is going to be 25 plus C and 25 minus C. Once you get the 4 boxes filled in, the time you divide, and because the times are the same, you set the times equal to each other and cross multiply. So at the equation you're going to solve is 54 over 25 plus C equals 46 over 25 minus C. And I know the speed of the boat, so I don't need to give it. I just need to write the speed of the river in my answer. So I'll set these. Oh, totally was off the screen here. Your box should look like that for 3. You should have the distances of 44 and 36. The number, for problem 5, it wasn't off the screen maybe. Distances 54 and 46. The number for the second sentence, because it's a boat speed, it goes before the signs. If it's a current speed, it would go after the signs. Once I get those 4 boxes in, I divide, set the fractions equal to each other, cross multiply, and solve. I think we'll just do these last 2 problems and call the section over. There are some plain problems that are in this section, 2 of them that we'll just skip because they're just like the boat problems. They're not particularly important. So I'm going to do 8. Notice I don't have the box set up. That's going to be the case on the test. The boxes aren't going to be set up for you. You might want to pause the video and try to do 8 without me, and then try to do 7 for homework. It's a boat problem, so I'm going to have both directions. The boat's traveling on a river going with the current and against the current. All the boat problems are structured the same. Distance, rate, time. First sentence gives me the distances. A boat travels 32 miles downstream with the current, and the same time it goes 8 miles up against the current. So with the current, the distance is 32. Against the current, it's 8. The rate box is boat speed plus current speed and boat speed minus current speed. The second sentence is going to allow me to change one of those letters to a number. It's either going to be the C's will both get changed or the B's will both get changed depending on the wording of the second sentence. In the second sentence, it talks about the speed of the current. In the second sentence, it talks about the speed of the boat is 5 miles per hour. My question 8 is different than your question 7, and these are the variations of the boat problems. So you have to be able to look at that second sentence and decide if the number goes after the signs because it's a current speed or before the signs because it's a boat speed. And in my problem, this is a boat speed, so my number is going to go before the signs. Your question, problem 7, when you get to it, that's different than this, because the number that you're going to be putting in is not a boat speed that goes before the signs. Your number is a current speed that goes after the signs. So our problems are the same, but they're different, and the variation of the boat problems are exactly that. It's the middle rate box. The C is the river speed or current speed. The B is the boat speed if there wasn't a current. So I have my time boxes set up. Because somewhere's in the question it says they travel for the same amount of time, I'm allowed to just set the time boxes equal to each other. If it said it took 1 hour less to go with the current, then all bets are off. It's a lot harder. I'm going to cross multiply and do 32 times 5 minus C equals 8 times 5 plus C. And then, not worth doing this without a calculator, left side's going to be 160 minus 32C. The right side's going to be 40 plus 8C. Now I'm going to minus 8C, minus 8C. This is going to give me 160, and then minus 32 minus 8, minus 32 minus 8. So 160 minus 40C equals 40. Then minus 160 minus 160. That will give me minus 40C equals minus 120. Divide by minus 40, divide by minus 40, and get C equal to 3. So my answer, I just need one number, the current speed is 3 miles per hour. Your answer is going to be the boat speed in still water is going to be whatever number it is. So your rate box, if you want to pause the video and try to do number 7, I'm not going to do it, but the rate box is going to be boat plus 2 and boat minus 2. The distance boxes are going to be 30 and 10, because this is with and this is against. And the time boxes are going to be those. So the big difference in yours is the number in the second sentence is a current speed, so it goes after the sign. My number in the second sentence with a boat speed, so it went before the sign. There are 2 problems in this section, 9 and 10, that I'm just going to ignore. It has to do with planes flying directly into the wind and directly against the wind. They're exactly the same as boat problems. The wind will work like the current, and the rate box will be plane speed plus wind speed, plane speed minus wind speed. You might be able to do those problems without me lecturing, but there's just one odd one, and they're not on the test. And I think we've got enough here in this section. You need to perfect the boat problems and the fast person, slow person's problems. Those will probably both be on the test. So that's the end of the new material. We'll go ahead and do the practice tests next. The tests are always just like the practice test, so you want to make sure you can perfect that practice test to make the test, tolerable.